So my name is Kostya, and here I'm going to present to you my struggles or experience in like a bunch of previous companies where I had the same issue over and over again until I think I finally found the best solution to that. And like one of the examples for that would be a company where I worked for in payments. We had like payment system. There is like a lot of things moving around for the configuration there. You have to connect to various external services. All of them have their own configurations. All of them have to be in sync. And how do you manage that? Right? So it's quite challenging because if you do something wrong, company is going to lose money. Maybe something would not going to work. It's a mess. And the funny thing is, it kind of happened before with me in like SMS, like telecommunications, in the networking, of course, where I needed to configure like very custom networking and like database setups. And it felt like every time people were doing more or less the same thing. So in that specific system, what do you think actually happened? Like people had the scripts, people had like a lot of things to configure all of those external providers for the payments, for like routes, for rules, everything. Super heavy. What do you think happened in reality? In the end of the day? Anyone? Just guess how it was managed. It was pretty much managed manually. So at the end of the day, someone forgot the script, someone forgot another script, external APIs changed, and nothing worked. So people went and just like manually started applying the changes. It was slow, irritating. Everyone hated that. So how it looks like is like you have some sort of idea of how it should look like. Your user tells you. So you have the script, and you fetch the external state from all of those APIs, probably many of them, and then you just compare them with what you have in your configuration and try to figure out what should be done, and then you just iterate. And if you had all of those things kind of interdependent, and like you should turn on one thing before you turn off another thing, and they're in different providers, you do it in the loop. And like, especially it's funny if you're doing this manually. So of course, you're going to have a bunch of issues with this. So one thing, like how do you even manage that, right? So like you have the dependencies. So what happens if one of them is going to change externally? So you don't control everything, and those external APIs that are paid for, that are not necessarily standard, are going to change. And someone can just log in there and change stuff, and things going to break for you. How are you going to handle that thing? Then what's going to happen, like if you will start applying your changes, and then your internet broke, or maybe you didn't type or somewhere, should you roll back? Should you apply further somehow? This is external API. And like applying changes to the APIs, like these API calls are usually expensive. So you can't just randomly revert things because, for example, with the payment things, if you ask a provider to stop accepting some sort of currency, they actually need to incur some costs because they need to have this currency in the bank. So they will start charging you from that moment. And then if you change the API back, they will charge you again. So you kind of need to think these kind of things through. And finally, how did you, even dependencies, like how would you do that? Like how would you figure out what should be applied first? So in your script, technically you should write some sort of graph. You should figure out what should be done and like do the topological sort of those to apply them in the loop. Challenging. So there is a better approach, of course, and many of you probably have figured out where I'm pushing this forward. And this is to use something like Terraform does. So you you utilize something like that, like something like OpenTofu, figure out what's going to happen, how it should happen, and once it's happening, like once you have the plan, you just go and apply it. And like unlike the previous slide, you see there is this new column here that indicates like infrastructure. So here it wasn't there. So here everything was free because usually get APIs that ask what's my configuration are free. So we making sure, taking from everything that it's OK, and then we apply it. No loops. We have calculated everything. So how should you do that? Like should you actually go ahead with the scripts? Should you go ahead with some sort of external system that's going to manage this for you? Or should you try and build OpenTofu provider? There are some kind of things to consider here. One of them is that, well, you have a Go framework, and there's like error handling and other kind of niceties that just comes with OpenTofu packed. You can handle different kind of timeouts and other kind of things. You do apply your changes idempotently. So if there is something changes and you're not sure you have applied, you just try again. It wouldn't work, for example, in the situations where maybe you have like a GUI that you would like to present, and you want this click to edit, click to apply scenarios. Like, don't go OpenTofu or Terraform in this kind of case. It's not going to be working nice. But overall, if you have something very complex in terms of state, like the dependencies, OpenTofu will be nice, or Terraform. If you have a situation where your team can work on these changes independently, and you want to prevent the locking, OpenTofu and Terraform has it built in. So you just can start with this and rely on OpenTofu for this. If you have already people who know how to do the Terraform, like HCL and other kind of things, if it's working, you should be, if you have people who are working with this, you can just ask them to help you to configure your system. And finally, like if you want to have your configuration finally in Git, because these kind of things probably gonna be a mess. And if it's in a Git, it's at least it's versionable, right? Sometimes maybe it's overkill, right? When it's overkill is like maybe it's very simple, like it's not that many providers. Like it's not that many resources, there are not that many dependencies. Don't bother. Like Terraform will have at least some overhead. Like maybe you can do the faster. If you have the UI, if you need to do the UI and click kind of things, no, don't go there. If you want to do some kind of reverse applications, like so if you do the changes and something broke and you want to automatically call some kind of APIs to revert things, if it's your requirement, OpenTofu or Terraform is not for you. And maybe like if you don't want to write on Go, that's probably, for now, not the way to go. But overall, the same thing as like normal slogan with the Terraform or OpenTofu. Like if you do this, you can focus on your logic if you go with the provider and don't do the plumbing, because the OpenTofu will do plumbing for you, which is pleasant, let's say. So I'm mentioning like Terraform and OpenTofu quite a while here. So what's the difference, probably? Let's talk about this. Well, OpenTofu is a fork. And this is one of those situations where like Terraform, which is a great product, which is a nice code base, always had contributor terms. So when you commit your changes to Terraform, you were always accepting basically that something can happen in the future that would change the license, and that's what happened. So now, technically speaking, Terraform is open source, but like not free, as people call it. So OpenTofu was born. Currently, it's under the umbrella of Linux Foundation, and it's still under MPL, while Terraform moved to BDSL. Terraform provider frameworks, though, and most of the Terraform providers themselves are still under HashiCorp, and they are still MPL. But OpenTofu maintains light forks for most of that, and they are ready to fork if something's going to go bad. So what are the providers? So basically, provider is a binary. It's just the plugin, and like plugin and provider in Terraform terms are more or less the same thing. There are almost, and by almost I mean almost like 100%, nothing else that can be called a plugin that is not a provider. So it's a binary. On the other hand, it implements certain API protocol, gRPC, which is part of the Terraform framework. And it's stored on one of the registries. They also have some protocol, and OpenTofu currently just serves basically directly from GitHub. And then OpenTofu or Terraform downloads this provider, they run it, they communicate with it, but they manage everything else. Like configuration is parsed by Terraform. Only like small pieces are sent to your provider, and then provider changes whatever needs to be changing, and the APIs returns back, writes some things in the state, and that's pretty much it. So provider only defines the schema, authenticates, like do the API calls, all of the things, and like effectively manages the remote resources. On the other hand, like Terraform or OpenTofu handles all of that. Like there may be multiple providers that are needed for your configuration. So OpenTofu will load all of them, make sure that they communicate with like each other properly, and all you need to do in your provider is basically do the CRUD operations and everything related to it. Okay, but one thing about all of that is that, like, of course, Terraform or OpenTofu provider on its own is not gonna do anything. You actually need to provide the configuration, and configuration is HCL. And I like to think about HCL as a sort of JSON kind of or YAML kind of data structure. They are not one-to-one, right? So, but with the schema and original files, you can translate one to another and back, right? So you can move from JSON to Terraform and from Terraform configuration to JSON with some things. Like I don't want to go too deep into this, but like if you were writing anytime TF files, well, you know there are blocks, and basically one block might mean different things. It can be either list or a map or an object, depending on the schema. And the schemas are different per provider, and there are global schemas for the TF files themselves. And I get a link here, and I will share the link with the presentation so you have all the links to like how actually it is done. But here's like how it actually looks like. So if you will have on the Terraform side some output variable, then well you can actually create the same JSON file. Like sometimes people do that. Usually it's done when you generate these configurations programmatically. But there are some twists there. You see there are like not exactly this not exactly the same. So in the one case you just use the variables, and in another case you kind of have to wrap them in curly brackets and prepend with the $, and some other kind of smaller things. But generally, what I'm trying to convey is that this is just a kind of a markup language. This is kind of the language to present your data. And here's like a lot of things that HCL can do for you. So the practitioners, people who use OpenTofu or Terraform, know how to use most of them. And the only ones that you need to care about as a provider development are the ones with the icons. So you see you have only 3, and maybe you only need 2 actually. And everything else is going to be available for you. So you can do modules with your provider. You can do explicit dependencies, variables, outputs, whatever. Life cycles, like make sure that something is not getting ever deleted and so on and so forth, just out of box, if you have the provider. So Even less? OK. So what you can create is basically the provider, which is like normal provider block. Everything inside is going to be somehow defined in your program, in the provider that you're going to write. Even less. Oh, no, it should be fine. And then the data blocks, which are more or less related to just normal GET requests. So you just fetch the data, ignore the state, and the resources, which actually manage something on the remote side. So here you will have a continuing analogy with like HTTP and REST. You will have posts, put, like delete kind of things here going on under the hood. But you still define everything with the attributes and blocks if needed to. A new thing that shows up in the new OpenTofu and new Terraform are provider functions, which are stateless things that allow you to add some new arguments. And like I would expect a lot of new providers are going to be just that, actually, because it's very often you just need like one small thing to check some variable that is too difficult to write. Otherwise, the regex doesn't really work, something like this. And people will, I think, will be just publishing kind of a few providers with just those, with just provider functions. So one thing about this is that in the provider, like if you give it a name, then all of the resources and data will start with the prefix starting with this provider. And then you will also have, for example, ability to request data from previous resources, either data or resources, by using usual HCL syntax for that. So here, for example, we have the ref, which will take value from computed value that is, you see, is not present in the data source, but it's a computed value, so technically it is. You would see it in state, and you can reuse that in your provider, in your resource, or anybody else, actually. And how you do that is basically the Terraform provider framework gives you a bunch of interfaces, and, well, you create your empty structures, and they not necessarily have to be empty. You can have some things there. But then you just make sure that you create some dummy variables that basically ensure that compiler will complain if you miss something. You just go from there. You just try to figure out what is needed to be there, look at the examples and sources and things like that. And there are some alternatives. So for example, there are a lot on the slide in the end. There are a couple of things. So there is this provider Go, which allows you to actually write Go code inside your HL, inside Terraform files themselves, and it's going to compile. And the Lua. And both of them are examples of Terraform functions, Terraform provider functions. Both of those examples are very low level. They're not going to use this TF SDK thingy. But they're only 500-ish lines of code in Go. So it's a nice thing to look at, and maybe you can even understand things better, even if you develop like standard Terraform providers. At the same time, you basically will have to, in these interfaces, implement like a bunch of functions. So for the provider, you only implement two, like schema and configure. Schema defines what exactly can be provided in the Terraform block, and configure actually reads that. Configure works a little different in like data sources and resources, but generally, we're going to talk about all of that at the workshop. So the workshop today is at 3. There are like 15-ish places there. And it's structured like a series of unfortunate events. So if you're going to join the workshop, it's not going to be me just presenting things. You're going to code things, and they're not going to work. They're going to break all the time, and we're going to fix them all the time. Hopefully, I had some security measures, safety measures, so the fallings are not going to be painful, but they're going to be happening. And if you're into these kind of things, please come. So, and that's it from me. This is the slides and the Terraform, the workshop repository. So feel free to look up if you're interested. and see you at the workshop. And now I think we have some time for questions even. Just come closer and ask it, and I will try to repeat it as well.
Okay. So there is like Terraform CDK that allows you to use programming language instead of HCL. What are your thoughts on using that instead of like HCL?
So the question is about Terraform CDK, which is a kind of newish approach, like few years, I think it exists for a few years, that allows you to write configurations on Terraform in a different programming languages. So you don't have to rely only on HCL. You can like write a JavaScript, Python, whatever. My thoughts about this is that it's not very supported. I think the use cases are limited. And I actually haven't seen it like properly configured anywhere. Like if you would see it somewhere, share the link with me. I stopped saying this because for now I think it's just no one is using that because if you want Terraform, you want it to look like Terraform.